So with that said, if you could all keep moonshot thinking in your mind so that you can ask our panelists some moonshot thinking questions, I would now like to invite to the stage 6 leaders who've been actively engaged in leveraging the campus as a test bed to seek game-changing solutions to 4 global challenges at MIT. And they're going to help us look backwards to set the groundwork for going forward. So I'd like to invite Joe Higgins, who's going to provide an overview for us on carbon neutrality, seeking carbon neutrality. I'd like to invite Mike Owu, who's going to join us on, give you an overview in terms of progress to date on sustainable mobility. Cecilia Talamantes and Rachel Perlman, who will give us an overview of campus materials flows. And Brian Goldberg on the stage with, we're going to have Ken Strzepek on Zoom, zooming in from Colorado today to reduce his carbon impact. And they're going to give us an overview of climate resiliency. And he's such a big personality that you won't even remember he's on screen. So let's take a moment and have all of you guys come to the stage. Thank you. I think you're up first, right? So the format will be Joe will present first, followed by Michael, followed by, I believe, Rachel and Cecilia, and then move on to Brian and Ken. Thank you.
Okay. Good morning, everyone. So I think we were going to start with a carbon neutral campus. So that's a really big idea. But I think what's central to that idea is really 2 things. So what can we do on our campus to sort of build towards this new energy era? So you heard Tony talk a little bit about all the activity that we have going on campus in a growth mode. But we really do need to think about this in terms of era. So we've gone from a coal campus to an oil-fired campus to now a natural gas-fired campus with our cogeneration plant, and that will evolve to a fusion-powered campus at some point in the near term. And what are the things we're doing ready to get to that? The other part to that is, how can MIT be a game-changing force in the market to drive large-scale carbon reductions? And we'll talk a little bit about that. But I think that's the core question, is what can we do here on our campus, but really to influence others, because climate is a global issue, and MIT has the horsepower right here in this room to actually make all that happen. So about the program, looking back, it all started with a goal. I do have a tattoo on my shoulder, by the way, when I got here. The 32% by 2030. And I'd just like to get by show of hands, how many of you have been working towards this goal since 2014, since it came out, since the Plan for Action on Climate Change? There's a lot of people out here that are working on a whole bunch of things. So there's really 5 areas that we've been focused on. The first is, as we grow, let's do it in the most carbon conscious way. So all those new designs that you see out there, we have a whole army of folks working towards doing that in the most efficient way possible. The second is transforming our energy infrastructure with the next generation cogen plant, which we have the team here today. We see that our ability to be able to generate energy cleaner than the grid can would pretty much neutralize most of all that future growth that is ahead of MIT. The large-scale renewable project at Summit Farms, we talked about that in previous forums here. The energy efficiency gains, there's a whole lot of work happening across campus, from buildings and fuel switching and the like. And then the last area is on-site solar. So we have a number of rooftop solar installations today. We have another 40 roofs identified where that would be a potential candidate to get us to our 32% reduction goal. So the successes to date, so we're happy to say right now we're at 20% below our 2014 baseline, so you should all give yourselves a hand for that are working on that. So also the broader impact that we're seeing. So we talked about being that game-changing force. We're going to share with you in a moment what the Summit Farms experiment has meant to the broader community. And lastly, we do now have, over the past year, we put together a 2-part path for thinking beyond 32%, and what it is that we actually need to be doing to get to a carbon neutral end game. So we're going to share a little bit about those 3 areas here. So we are seeing success. So back in 2016, MIT partnered with Boston Medical Center and Post Office Square for a cost-neutral model of aggregating partners to build a large-scale renewable energy project in North Carolina. It's a 60-megawatt project across 160 acres. But what we have seen is since we announced that to the world, our phones and emails have been blown up by a number of different institutions all across the United States saying, oh my gosh, a cost-neutral model, how did you do it? Tell us about it. Tell us about the research aspects of the program. Tell us about how the REC treatments work. Why is it in North Carolina? Tell us, tell us, tell us. And Julie and I spent the better part of the past 3 years, informing and working with all of these organizations that you see listed there that have, now have exceeded a 10-fold impact of what Summit Farms is. So we've gone from 60 megawatts to almost a gigawatt in production, in development right now. Just the other day, Johns Hopkins University announced that they'll cover 50% of their energy footprint with a solar installation in Virginia. It's one of the largest projects. It's 3 times the size of Summit Farms, and they were the first ones to call us the day after we announced. Boston University announced their large wind power project in South Dakota. We totally flipped their thinking. They were thinking solar here in Massachusetts, and we'll get to that in a little bit. They're like, we got to do wind in South Dakota. Brown University, they have a wind farm in Texas that they announced and a solar installation here in Rhode Island. So how do you get that multiplier effect? It's really sharing everything that we did. And then just this past summer, if you look back here, City of Boston, Mayor Marty Walsh, had all the mayors from across the country in these cities, and he said, MIT inspired us. We can do this too. If MIT and Boston Medical and Post Office Square can get together and develop large-scale renewable energy projects, we can too. And you see the number of cities here that signed up for that challenge. And we're looking at a 50 times impact for that. So that's how we get sort of that game-changing force in play. And it's going beyond just cities and colleges and universities. Just in the past couple of months, we see now large corporations aggregating their purchasing power to developing new projects to decarbonize the grid faster and faster. So also another success that we've seen out of this was rethinking location decisions. We always used to think that we got to build these projects in our backyard. When you think about grids, the United States has about 13 electric power grids going from the cleanest, like we have here in New England, to the dirtiest, as we see out in the Midwest. And if you're going to be spending hundreds of millions of dollars of projects to take carbon out of the grid and out of the atmosphere, where are you going to spend those hundreds of millions of dollars a year? So that was an idea that sort of changed the thinking of the whole industry, getting a Boston University to go from Massachusetts to South Dakota. As you can see here, the carbon intensity of the grid in the red areas is almost 3 times that of what we see here in New England. And that spurred a much broader thinking from the higher ed learning groups. So as you can see here, Boston University, Boston College, Harvard, MIT, Northeastern said, hey, maybe we need to be thinking about how we do the actual accounting for emissions in the country. We sort of have this draconian emissions accounting program that we started years ago just to kind of get everyone on the ship. But maybe we need to be thinking globally and not just locally. So I think that there's some new ideas that MIT and the group here is putting forward out there in the world as a game-changing force. So we're also thinking of a new milestone, so beyond 32%. So there was a lot of work this past year where we put that question out in a number of different forums, engaging with the MITI's low carbon centers and all the technologies and the advancements are happening there. The Climate Action Advisory Committee, chaired by Maria Zuber, and the class that Julie and Tim Grakowski that we heard about last year, having the actual students, from across the campus, giving them all the facts and say, here's what we have, here are all the things that we can do, you solve it for us. In a number of different ways, really brought a collaboration aspect to what this path looks like for MIT going forward. So we're here to kind of share with you the result of a lot of that work. So thinking beyond 20% or 32% reduction, there's really 2 paths. The first one is on campus. So we are going to continue to make investments in energy efficiency, energy efficient designs, and how we kind of continue to transition towards that new energy era. Battery storage is getting better, fusion is getting closer. There's a number of different things, tipping point technologies that we're keeping an eye on, but they're just not here yet today. But there's steps that we could take to start to move in that direction. But we can't wait. So I think there is this sense that there is a new urgency out there. We heard from the IPCC this past year. And what are the things that we can do as an urgent call for action globally to expedite carbon reductions? So we'll walk you through, here's where we're at today. Our emissions is about 213,000 metric tons is what we put out from the campus in 2014 as our baseline. Today we're at about 200,000 metric tons, and that's mostly the result of fuel switching in our central utility plant, energy efficiency gains in our buildings, and the grid here got a little bit greener from much broader efforts across New England. But building towards the next energy area, the steps that we're taking are the second century cogeneration plant that Tony talked about, the transition from steam distribution on campus to a hot water distribution, just like Harvard's doing in their Alston campus. If we did it all new today, we do it all in medium temperature hot water. So there's some investments that we're making in transitioning that thermal infrastructure. There's some things around machine learning in our building technology and how we become more efficient in the set points that we have in our buildings and the schedules that we keep. And the grid will continue to get greener. So the new energy era, things that we're keeping an eye on, renewable fuels are starting to make some significant progress. So what we can burn in a renewable way for combustion to make power and electricity and heating and cooling for our campus. A large offshore wind development could prompt an electrification of the campus, so that's something that we're keeping an eye on. Geothermal is a good possibility. Energy storage and fusion are on the horizon. So we see that as the pathway forward here on campus. But what can we do globally to offset these emissions? So Summit Farms, if we take credit today for what it is actually avoiding down in North Carolina, it's about 90,000 metric tons of carbon avoidance that we're actually physically measuring in North Carolina today. So what would we need to get to a net zero sort of condition within the next year or so? So we would need another basket of projects. Well, we're going to talk a little bit about, we're making some progress, but how much would we need? We think we would need another about 90 to 100,000 metric tons of avoidance from out there with some renewable projects or other carbon projects. So as you can see here is that we can act sooner with sort of these market instruments in terms of avoiding carbon globally as we continue to make investments on the campus as they make sense as the energy infrastructure evolves. So what's next? So where are we going to get that 90,000 metric tons of avoidance? So we're thinking even bigger this next time around. So we're seeking aggregation opportunities with the City of Cambridge and Harvard, Wellesley College, and many other municipal-like companies, utility companies. We see this as a new model where we can allow many more people to do many more things in a whole basket of projects. And Steve Lanou and others are leading that effort with the city and Harvard. So stay tuned, but I think the goal that we have for ourselves is 1 million metric tons of carbon avoidance per year. So that might be a basket of projects that get implemented across the US or even internationally as the strategy evolves. So as we talked about the infrastructure, so we are actively converting our infrastructure with projects like the College of Computing in terms of all hot water infrastructure would come from the central utility plant to support those types of projects. So we see an emissions avoidance opportunity on campus of about 5 to 10%. This is going to take 40 years to implement. This is hundreds of millions of dollars, and it takes time. The main group is all steam heated. I mean, imagine changing out 2,000 radiators across the main group. But we are going to do it opportunistically over time, and that's the way that MIT has evolved its infrastructure from over 100 years ago. And then the last area that we're really excited about is many of you are familiar with the Nest, right? The thermostat. So it knows, occupancy if you're around. It allows you to change the set point. It sort of learns your habits and it changes your set points and for your heating and cooling. And you can save about 7 to 15% in your house. There is no Nest for large commercial buildings. And we took that on as an opportunity to say, hey, let's build one. And we put that out there at the MIT Energy Hack, which is in its 3rd year. 200 students came across, attended from all over the world, and we put this challenge out, hack MIT's smart sensor for our buildings. And they actually did it. They gave us a machine learning framework that we are actively pursuing in pilot basis to use on the campus in a couple of classroom particular environments. But we see this opportunity as even much more than a 5% total emissions reduction on campus. So stay tuned. That's a very significant area that we're very excited about. So with that, I'll turn it over to Mike.
Thank you, Joe. I've got to figure out which button I'm hitting here. Green arrow. Nope. The big one. The big green arrow, sorry. All right, here we go. So my name is Mike Lowe. I have a day job, but my other job is chair of the Transportation and Parking Committee at MIT. And that's my role here as I address you this morning. Hopefully you're all familiar with MIT's Access MIT program. I'm going to talk a little bit about that program, how it came about, and some of the early results that we're seeing. So we set out at the beginning, this was several years ago, to figure out how we can reduce parking demand on campus. And parking, there's lots of implications of parking. It relates to, obviously, greenhouse gas emissions. It relates to congestion on the streets. And there's a significant cost of providing parking on campus. So we wanted to figure out how to do that. We launched the Access MIT about 2 years ago, 2.5 years ago. And this was the launch was 2.5 years ago, but the process actually took us many, many years. We first started literally 10 years ago. I looked through my email this morning. Some of the early conversations started 10 years ago. So this has been a long and challenging journey. And it was a very collaborative process. A lot of people were involved in actually developing the program, testing it, piloting it, and then finally launching it in 2016. I like to call it a few groups because they really played a critical role. So the Transit Lab, I don't know if anyone from the Transit Lab is here, but the Transit Lab and many, many series of graduate students over the years were involved in coming up with some of the early concepts. We piloted it over a number of years. Obviously, the Parking and Transportation Office with Larry a few years ago, and now Tom and Robin, who are here somewhere, have been partners in this process. Obviously, they're the ones who are on the ground, and this couldn't happen without their full support and collaboration, and we're counting on that going forward. Institutional research, faculty, staff, the Transportation and Parking Committee that I chair has representatives from grad students, undergrad students, so multiple players have been a part of this process, and in the last few years, the Office of Sustainability has been central in trying to bring it together and tie it more closely with the overall institute goals. So Julie and Susie and Derek and others have been really key to get us to where we are today. So let's see. So the shift to daily parking pricing. The program itself, hopefully, again, you're familiar with it, but it's a free universal bus and subway transit pass. This is a chip in the card, the MIT card. MIT was actually the first, one of the first, if not the first, to collaborate with the T to put a Charlie chip inside an MIT ID card. So hopefully you all have that in your ID cards. And that gave us huge flexibility in how people can use their card and access public transportation. So free universal access on the subway and buses. A shift to daily parking. This was a central concept in the program. And really what it allowed us to do is encourage individuals who are commuting to make a daily choice as opposed to an annual commitment to a single mode. And that shift, that flexibility is really critical to the success of the program. Recognizing that not everyone has easy access, and some people do have to drive or take other modes, we increased the commuter rail subsidy, and we also provided subsidized parking on the MBTA stations, 50% subsidy on MBTA stations. And then finally, not on the slide, but we've also been continuing to expand our bike parking program with racks, placing bike racks pretty much anywhere on campus we can find. I should back up for a second. When I say we, I'm really not talking about myself because I'm not doing any of this. There are many, many other departments and individuals on the ground who are really implementing these programs. So one of the things that was critical in this process is as we're shifting to this new system is making sure that we're working with a consistent data set that we can measure, track, report on going forward. There's been a lot of changes to the parking system. We're changing technologies, we're changing systems, we're changing programs. So it's important to make sure that we're working with consistent data that we can measure and make sure that we can report on accurately. So this chart here, this is showing analyzed data. This happens to be MBTA riders over the course of the year. We have similar data for parking gate access and T-Pass subsidies. But you can see from this graph is there are some gaps in it. Where there's a white line, there's no space, there's no bar. And that's either missing information or something else happening. Maybe the data was corrupted, maybe we didn't get the full information from the T. So in order for us to be able to use this data in a meaningful way, we needed to make sure that it was accurate and not skewed by weird things happening. So Derek, who is sitting here somewhere, where's Derek? Right here in front of me. Derek and his team, working with a grad student, have been using machine learning to fill in the gaps for both the parking data and the transit data to make sure that, again, we're using good source data. And so what you see here is the results of that analysis that really fills in the gaps. Where there isn't a bar, it's probably a holiday or a weekend or something like that. And part of the analysis is also helping us now understand if the bar goes down, is that because of a weather event? Is there something else that's influencing it? And that type of information analysis is critical to our ability to really understand the data that we're looking at. So how are we doing? So this is a simpler version of that same data. This is MIT riders. This is an average day riders. You can see in 2016, we were looking at about 3,100 in 2016. After we implemented the program, that went up to 4,200, and we saw another little increase in 2018. I should note that we continue to scrub the data and continue to analyze it, but we're trying to create a solid baseline going forward. Similar information on permit purchases. So these are individuals who are buying parking permits. We've seen that go down. So again, this is encouraging information. We don't know necessarily whether all these changes are directly related to the Access MIT program, but we believe that has a significant impact on it, and that's, again, something that we're going to be studying going forward. And then parking gates. So this is people tapping to get into a parking facility. This happens to be the gated lots where we have more accurate data in the past. But again, we're seeing a reduction in people driving into the campus on a daily basis. And then finally, blue bikes. This is the last piece. Huge increase in blue bikes use on campus. MIT subsidized that program. I think the MIT blue bike stations are the most heavily used in the system. So again, MIT is a heavy supporter of that program. So going forward, the goal is to continue, now that we have a solid baseline of information, to continue to track that information and continue to explore opportunities to do even better. Really using data, because MIT is all about data, and making sure that we can explore opportunities across the system, both on parking, transit scenarios, carpooling. We've launched a program to explore that. And then, obviously, bikes will continue to be a major piece of MIT's transportation systems. Thank you.
Do you want to hit that thing? Mm-hmm. The next two presentations are going to include pairs of people to demonstrate. You can both introduce yourselves, Rachel and Cecilia, to really give you the sense of the essential team effort involved in this complex problem we're trying to figure out. So take it away.
Hi, I'm Rachel Perlman. I'm a PhD candidate in the Institute for Data Systems and Society, and formerly Engineering Systems Division. And I'm here.
I'm Cecilia Talamantes. I work in VPF, and I'm, I guess, the procurement czar of data.
So the project that we've been working on, many of you have been involved and have heard about this, is we're looking at the material flows of MIT's campus. So the central question was, how do we measure the material flows of a university campus using MIT as a case study so that we can, kind of in the broader picture, identify opportunities for reducing the environmental footprint of consumption. And MIT, kind of from the academic perspective, it's more of a closed system, so presented some opportunities, but it's also a really complex system. So this has been a really challenging project, and it's involved a lot of people in the room, collaborations, to break down this system. So the way that we've been working on this is by taking a step back and thinking about all of the things we as a system are consuming and disposing of, breaking it down into the pieces. So lab supplies, equipment, IT, food, all of these different streams. We haven't, in this project, we haven't included construction and demolition, so that's kind of out of the scope. And to look at these inflows, We've been using property office data. We've been using the procurement data of what we're purchasing. The property office data has also provided insight into like when a property is tagged, activated and deactivated, looking at the lifetimes of products and the stocks. On the outflows side, we've been using a lot of facilities generated waste data, EHS data. I did a lot of waste audits to understand the composition of waste. So in the actual trash and recycling, what are the components besides just knowing the total volumes of waste? That involved a lot of student volunteers, staff with Ruth Davis, and then qualitative characterization, so interviews with purchasers, going to procurement, understanding how the system works, talking to sourcing analysts who determine contracts with people we buy products from, and understanding the vendor's perspective and what kind of data they can provide, and the quantitative side of looking at the environmental carbon footprint of consumption and of waste. So we'll talk a little bit about a collaboration.
Okay. So I originally met Rachel in 2015 when she started her PhD project. And in the beginning, it was hard for me to understand exactly what she was trying to get at. But slowly, our relationship evolved. And I have to say that what she's been trying to do has been very difficult, at least from understanding exactly all the types of procurements that we do and exactly how that kind of translates. So I'd have to say that one of the things that when we were putting together these slides, I said to Rachel that her being part of MITOS was so critical to providing some credibility to her as a student, because I think sometimes as administrators, you know, those of us that are involved with students, it's really hard when a student does come to us. And I have to say that this whole relationship has provided me, at least, with something kind of fun to do that's a little bit different, and actually looking to see that we're making an impact. So with that, I'll let Rachel talk about the other collaborations that she's had.
Yeah, and so with MITOS, Julie, the director of the Office of Sustainability, is on my committee, so it's been a very integrated process. I've worked with Brian Goldberg in the Office of Sustainability as a fellow, and probably at different times worked with everyone within the Office of Sustainability. We approached the VPF to understand the procurement process. So to understand what kind of data there is, how specific it was, why there was a lack of specificity in the data when that was the case. Working with the property office, Erin and others. On the academic side, having my committee guidance, so John Fernandez is my academic advisor and the chair committee and chair of the committee, and Tim Gutowski is also on my committee with Julie. I've also been working with a UROP, so there's a lot of academic sides to this. And then in facilities, working with Ruth Davis, Jared to get waste data, EHS to get other waste data, so hazardous waste, medical waste data. So also talking in facilities with mail services, custodial services. So it's really been an integrated process and a learning experience for me to understand how the Institute works. And it's really been this kind of collaborative process of research, operations, and the Office of Sustainability.
I think the project is actually, it marries very well with this whole idea of using MIT as a lab. So I commend Rachel in her tenacity to motor on. So one of the things we wanted to talk about is what we've actually learned. So just so people understand, when a student comes and says they want data, I mean, the first thing that you do is say, what for? So originally, when we first started this project out, I talked a lot and learned a lot about how you go about doing a greenhouse gas emissions calculation. And with that, I kind of said, OK, well, I know a set of data that we could give to try to do this. That set of data that I had originally given to Rachel was essentially just 3% of the total spend. Here you see that we met back in November, and then we talked a little bit more about providing more data. So from November to, I don't know, sometime a month or so, I don't know, I sat down with Rachel, and essentially we've been able, or she's been able to, with the data that we provided her, was able to determine that 13% of the spend she was able to equate to 79,000 metric tons. So one of the things that always is helpful for me, as I'm not a scientist person, is to equate that to something that I can put my arms around. So that's why we have a couple of things, little visuals here. So I felt like that was very telling. But the more telling thing is the remaining 87% of our spend, and how would we go about actually trying to calculate greenhouse gas emissions on that.
And that 87% includes services and other spend categories, and that 13% is our best estimate at materials.
Okay. So I guess we'll just move on to what's next. So go ahead.
Yeah, so for me, I'm in the process of completing my dissertation, wrapping up the results, lessons learned, providing it to the Office of Sustainability as well, to the larger community, and developing recommendations, and also presenting at the Sustainable Purchasing Leadership Council. So it is really thinking with Brian of looking at the life cycle of products from the beginning to end.
And so I had to kind of step back and think about this. So essentially, this whole materials flow analysis was all about materials. And in reality, there's probably about another 20% of spend that is attributed, we think, to materials. But in partner with Rachel, it would be a very difficult task. So one of the things I've always challenged the Sustainability Office is, how do we go about doing this measurement, and how it's going to, we're going to need buy-in from the entire community as to what this means to actually do this calculation, because it is so difficult to do given how our data is represented. So, I mean, I'd like to see us do stronger collaborations with stakeholders, and we would also need to have some sort of a data governance. It was very, very difficult to figure out what we could do with the data, and that is some guidance that I think would really kind of help this project move forward and actually make it more, pardon the pun, but sustainable for the future. Because I think once you do a measurement, there's always this demand to redo the measurement over and over again. So that's the other sort of task that we have to consider. Thank you.
Thanks.
We made a promise to Rachel that we would get her through her dissertation soon. Thank you, guys.
Hello, I'm Brian Goldberg from the Office of Sustainability. And I'm Ken Strzepek, is a research scientist here with the Joint Program for the Science and Policy of Global Change. And Ken he's with us, he'll be listening, he'll be watching, and then I'll hand over to him. He'll share a few thoughts as well. Jumping in, let's see, I think green arrow. Oops.
Big button.
This says green arrow, and I'm colorblind.
Oh, I forgot. Big. It was big.
What am I?
The big button. Big.
Oh, the big one. Okay, there we go. When I showed up on MIT's campus 3 years ago, Julie assigned me this first task of how to grow a campus that is resilient to climate disruptions and intensifying climate impacts. And this was a really big challenge to solve, but I was ready to take it on. That's why I was here. This is a challenge that at MIT, through our work, we're trying to solve climate resiliency by asking the question, how do we enable the campus to continue fulfilling its mission, doing what all of you do every day, but to do that in the face of emerging risks that we're learning about, a lot of uncertainty, and a lot of complexity about what does all that uncertainty with climate mean when it actually impacts our landscape, our buildings, our utilities. So it's a very complex set of challenges. It requires a crystal ball, and it requires a lot of comfort of grappling with uncertainty. So that's the challenge we took on. And one of the ways we started approaching this challenge was to break the campus into some smaller parts, because it's a very complex place. There are spatial dimensions of how to understand what do climate risks mean when they actually come down to the campus. So we broke the campus into 4 parts, or 4 systems. It made it a little bit easier to tackle this broader challenge. And when we view the campus as a series of these systems of community, the things, the people we are and what we do, the buildings, the infrastructure, and the site, we begin to see the challenge in easier to digest terms. So for example, if we were to build the world's most flood-proof building, that would sit in the building's layer of the system, but the world's most flood-proof building would require utilities that are coming from outside of the footprint of the building and the budget of that building project. So suddenly we need to think about a resilient set of utilities or electrical infrastructure serving the building. And then if there's a flood around the building, people who need to be in the building wouldn't be able to access the building. So suddenly, just the thought exercise of thinking through how one building can become resilient requires thinking through the interdependence across all these 4 systems. And that's just for a new building. We still have 160 buildings that are existing. So the challenge is immense, and I alone could not tackle this. So I needed some people to help me figure out how do we reduce the uncertainty of this challenge so then we can manage these risks. And we're at a great place because we have an incredible research team. Ken, who's with us here, we have Carrie Emanuel, Jake Jacoby, folks from the Joint Program on the Science and Policy of Global Change. They're the world's experts in understanding the climate risks. At the same time, we have the world's experts in understanding the MIT campus, and that's many of you in the room, and this whole list of offices that we've engaged with. So I just wanted to ask you, if you've been involved in our work to date through the committee, through our technical working groups, if you could just stand, and I'd like to just give you a round of applause to thank you for your contributions. You know who you are, and I'm going to start calling you out. I see Emma and Janine and Ken and Carlo, whoa, Joe, Mike, Phyllis, Soumya. So thank you, because it's really taken all of us together in a feedback loop between research and operations to tackle this. So thank you for standing. You're a very humble group. So with this collaborative platform of people that are experts in research, experts in the campus, we've now been able to do some things. And an additional partner of ours is the city of Cambridge. In 2015, as Tony mentioned, the city started with a map of the city of Cambridge's flood risks. Some of the data was incomplete because we, MIT, didn't have our own understanding of a lot of the data, so that didn't get into the city's mapping, so there was a gap in the campus. We quickly jumped on tackling this issue by understanding our stormwater system and studying the system, by engaging with the researchers to develop how do we take research models with a little bit of data to make some projections and predictions, because we have to start somewhere. And then we brought that research to the operational leaders. And the operational leaders, many of the people who stood up in the room, said, well, boy, this is great information, but we don't have enough data here to really be certain to inform our planning. So we actually need more data and more certainty to be able to bring this into our planning. And thanks to the leadership in our EVPT group, we got the funds and the support to then build out a campus model and take the next steps to complete what the city had started. Collected a lot of data points, and then have ended with a fairly kind of refined model that we're currently working through over the next few months to help inform decision making. So it's been really a wonderful collaboration. In terms of outcomes, and I'll ask Ken to speak to this in a minute, I think we've definitely demonstrated that this research and operations partnership is essential. It's the researchers who have been able to show what's possible, and then it's the operations experts who are able to say, well, I see that's possible, and here's what I need to be able to make decisions. So that partnership has been tremendous and essential. We've also developed this town-gown partnership even further by demonstrating how we as a campus can work with the city in a back-and-forth process over many years to advance our collective understanding. Preparing for climate means we have to adjust across our boundaries, and our ability to do that hand in hand with the city has been tremendous. Ken, I think if you're with us, if you could speak just to some of the values and outcomes you've seen from a research perspective.
Good morning, everyone. Can you hear me? Great. So this has been very exciting to be part of this. And just a quick digression, I have been walking the campus since 1973, and we have seen a great change in how technology can affect the campus. As a young undergraduate, when a snowstorm would come, we would anxiously hope for 30 inches of snow, have a day off, but we wouldn't know till 6 in the morning the next day. But now, 40 years later, what we find out is decisions are being made a day ahead of time to close Boston, to close the roads, to close MIT. And that's because the technology of weather forecasting has changed dramatically, and much of that coming from Building 56 here at MIT. So as we move forward, this uncertainty that Brian was talking about, which impacts planning decisions and operation decisions, is totally changing. And so one of the things that we did when we came together is there was a lot of uncertainty about MIT's flood risk in the current world because we had just not had the model. So we were able to reduce a bit of that risk by building models. But as we look to the future and how climate will change, this adds uncertainty. And then also, as we looked at it, people make decisions based on risk. So one of the big outcomes we found out is that the risks of flooding facing MIT are not a single risk, but we have 4 seasons and we have 3 risks that we face. We face risks of hurricanes, from water coming down the Charles and water coming from the Boston Harbor. We have risk of sea level storm surge coming from nor'easters, which we've been seeing recently in the Boston. And then we have the issue in the summer where we have cloud bursts or flash floods that could occur at any time over the campus. So the issue is not just one risk, but these 3 risks. And so if we want to say what is the 1% risk per year of a flood on campus, it isn't a single event. And that is a very difficult meteorological statistical issue to address. And we are turning it around and going back out to the campus and those experts on campus that deal with this to help us understand that. The other thing we learned is it's not just technology, it is about institutions. And that MIT is not an island, but its flood management is a function right now of what happens in Cambridge and how Cambridge works, what happens and how Deer Island in Boston works, because many of the pipes are connected in combined storm sewers. And then finally in 2070, as sea level rises and storm surges get greater, MIT is a function of what Boston does in terms of its flood protection at the Charles River, et cetera. So thank you so much.
Thank you, Ken. So just moving to what's coming up next. Over the next year, we're in a process of harmonizing our model with the city so that now the campus and the city have the same model and can work on that model together and make decisions together that are speaking the same language. And also working with many of you to inform the process. And as we move forward, as Ken mentioned, we're trying to get a better sense of flash flood risks. We're trying to make some of this information more available. And I'm happy to speak further about next steps. Thank you.
All right. So thanks to all of you, and I hope you can see the connection from where we started of looking at the global challenges and the direct connection to the campus, both challenges, what we have to solve for on campus, and leveraging the campus as a test bed. It also demonstrates what we see as the essential partnership between the academics and the operations in analyzing, studying, and building solutions together. And I think we'll have a chance to get more into that on the second panel, looking at education. To wrap up with our final minutes, first of all, Joe, I didn't know about your tattoo. That's new information. So I'll have to, I hadn't considered that, but maybe you're a step ahead of me on that one.
If anybody wants one like it, you can come see me after the talk.
So I'm going to start with Mike and Joe. So for both of your initiatives, mobility and greenhouse gas mitigation, goals were set by the Institute. So for those of you unfamiliar with it, in the case of greenhouse gas, we set a 32% reduction below 2014 baseline by 2030, which Joe had walked through. And in the case of transportation, it wasn't as widely broadcasted, but internally we had set a goal of could we reduce our, I think in the end we determined single occupancy vehicle demand on campus from a 2016 baseline by by 2018 to understand what the impact. So for both of you, maybe starting first with you, Joe, is how did having a goal to strive for and being held accountable to, do you think impacted the efforts and the way we organized moving forward?
Sure. So I think nobody signs up for a 32% by 2030 tattoo because it's a random number, right? So what makes it effective is it's a SMART goal. Has anybody heard of SMART? Mm-hmm. So it is very specific, 32%, okay? So we all know what that is. It isn't just reduce emissions. It's measurable. So we all agreed, like, yes, we can measure this. That's not a heavy lift for us. So that was kind of the second thing. The other is it achievable? And I think we all looked at each other and said, yeah, I think we can all, if we all kind of work together, we can kind of do this, 32%. The fourth is it relevant? So if you're going to sign up for something, you don't want to sign up for a random number that's handed to you. And when we looked at the 32%, it comes from the IPCC, the federal, the city, the state. Everybody was working towards this same number of, we need to get to about 32% by 2030. Now it's a little bit more aggressive. But it was harmonized so that we all internationally, locally, are all working towards the same goal. So scientifically, it was relevant. So I think that's important to remember how it helped us. And the last is it's time bound. So we all know we're going to be here in 2030, right? So we better get to it. But I think that's what made it all happen when all the team had to come together to do this hard work, is it was a SMART goal.
That's great. Thank you so much. And Mike, on the Access MIT?
What he said?
The tattoo part? Or the,
no.
Okay.
But in addition to what he said, because many of the same issues apply to the transportation program, Access MIT. I think with Access MIT, setting the goal was clearly critical for all the reasons that Joe described, but also changing behavior is a huge challenge. It's not an easy thing to change. MIT already has one of the lowest SOV rates in the area, so we knew that we were already doing a really good job, and so we were trying to do even better. So our goal, again, it was 10%. It was over 2 years. It was aggressive. We were relying heavily on projections that the faculty and students had made, but we felt it was important for us to actually have that goal so that we could really measure it and sort of see how we're doing. And in part, it was also because this experiment, and really it is a large-scale experiment, is a very expensive experiment. MIT is spending millions of dollars every year to provide this program. So how MIT uses resources, financial resources, and other resources is critical. We can't just throw money away. And so we need to make sure that what we were doing actually was measurable, had an impact, and benefited the community as a whole.
That's great. And I would argue from our vantage point, working with the remarkable work Derek's been doing, it's really enabled us to expedite the collection of that data with your groups and beyond, so that we can have a baseline that all of you can trust moving forward. So thanks for that. I just want to move on in our final moment or so here is with the teams, Cecilia, Rachel, and then Brian and Ken, what do you think is the ongoing value proposition for these staff researcher, faculty, student, whatever combination, partnerships in advancing sustainability on campus? And either of you also may be seeking a goal, so feel free to comment on that as well. So why don't we start with Cecilia and Rachel? Anything added? You spoke to that a bit in your presentation, but now that you've heard everyone, is there anything else to add to that?
I think that having these research relationships really kind of provides a completely different view into the day-to-day work that I do here at MIT. And I mean, I would very much love for this to happen with more people so that more people can see it. In our particular project, it was really difficult for the things that I mentioned before. Right now, we have really no guidance on our data and governance of our data. And as I think we evolve, we're going to need to do that because it's going to be very helpful. I have other students that want to do projects that have to do with greenhouse gas emissions and measurements. So I guess my plea is to the community and see if other people are interested in actually doing this. And like with anything, it takes a village, and this is a village. So yeah.
Thank you.
It's also expanded to the scope 3 analysis beyond just materials with Jeremy and others. And I also think that it just makes the project live on, and the results kind of have the opportunity to be institutionally incorporated. So like it'll live beyond a student's time at MIT.
Right.
That's a great point. I think that's one of the pieces we've really set out to do, working so closely with you, is to make sure it's not just a project on the shelf that we don't know where to find down the line, or on my desk where you couldn't find it, but rather something that can live on and be integrated. So,
and that's the commitment that I think we need to realize, is that once Rachel is here and she's gone, and this always happens, is that people want to know it again. So it's really, it is an institute commitment.
Yeah, thank you. Brian and Ken?
Yeah, Ken, if you want to jump in?
Yes, I'm going to speak as a researcher. This project has been incredibly important. Professor Emanuel and I have been working, ironically, in 5 different places around the world on the same flooding issues. But now, as we turn to our campus, for a number of reasons, research-wise, it was very important because, as I mentioned before, most of the risks are a single risk that we were able to look at. And we come here, and in the climate variability change, it is these multiple risks and trying to understand the changes in those, which are very complicated. But also, as someone working in resilience and planning, and with Brian, is to see that these are multi-institutional, and that as you plan infrastructure, the constraints on you and the position in which you sit within different governments and different regional activities, those are quite important as we look at how people work together. And then finally, working together with the Office of Facilities has been one of the highlights of this for me, is seeing the professionalism and also caring for the Institute as an alumni as well. How can we serve that? How can we do all of that? And in terms of that, and so that has been really important to all of us here.
Thanks, Ken. Brian, anything to
Very quickly, I think freedom. I think when Ken's in the room with a bunch of engineers and folks in facilities, and Ken is asking in his academic way questions, it kind of gives everyone permission to sort of put on their student hat for a minute and think broadly, and it's okay to say anything. And Ken seems to create that environment, and I think that's the value of getting practitioners into that academic space.
Great. Well, I can't thank you guys enough. I'm totally inspired. And remember, the kickoff of this panel is to think about where we started off 5 years ago and what has now transpired in a relatively short period of time in terms of new partnerships, deepened partnerships, amazing work, potentially a dissertation to be done by July 2019. We'll let you all know so you can come see Rachel present, and ongoing work we all have to do together. So if you could give a round of applause to our first panel, that would be great. Thank you guys so much.